let's start with magnetic field at a distance from a magnetic pole. So in our previous classes we have seen that a single pole can be either a south pole or a north pole. So now we will see due to a magnetic pole at a distance, what would be the amount of magnetic field. So for that, first let us imagine there is a circular current loop. So in this case, we are going to take an approach of magnetic field due to the current loop, as we may not always try to work out with a single pole, because single pole doesn't exist. So if we have to calculate for a single pole, the magnetic field for a single pole, we will take help of this current loop. Suppose this current loop is carrying a current I and it is having a radius R, and we already know that at its center there will be a magnetic field B, which is mu naught by 4 pi into 2 pi I by R. So this is already, we know, this would be at the center of this current loop, the magnetic field due to this current. Now suppose we keep a magnetic pole at its center. Suppose we keep a north pole, and this is a bar magnet with a pole at the center of this loop, and this north pole has a pole strength Qm, right? So this north pole would definitely feel a kind of force due to this current loop, right? So what happens is, now what we will do a little change in this magnetic field before going to introduce that. We can write it as mu naught by 4 pi into 2 pi r I by r square, right? Multiplying and dividing by r. Now for this loop, this is a current carrying loop. Suppose the length of this loop is L, and therefore this length will be equal to nothing but 2 pi r. So 2 pi r is the length of this loop, and we can say that mu naught by 4 pi is nothing but L is what is the length of this loop into I by r square. So therefore the magnetic field B becomes mu naught by 4 pi L I by r square. So this is a magnetic field due to this current loop, and at the center we have imagined a north pole with a pole strength Qm. Now as we know that this north pole, if it is kept at the magnetic field B, it will feel a force F, which is the magnetic field B into the pole strength. So this is the magnetic force that this particular pole will feel if it is kept at the center, and this field would be due to this circular loop. So definitely if this is the magnetic force B into Qm, so we just substitute B value. This is due to this B, which is mu naught by 4 pi L I by r square into Qm. So this is the force that the pole will feel. But also we know that this force is the same force given by this particular loop. So the another knowledge that we know that the magnetic loop would give a force which is equal to B into I into L. So this is the loop that will give this force, and the loop will have a magnetic field B, and it is carrying a current I, and at a length L it will give a particular force F. So this is the same force which is felt by this particular pole. So we can write that BIL is equal to this force, which is mu naught by 4 pi into L into I into QM by R square. Now from here you can very easily find out what is the magnetic field B. B will be mu naught by 4 pi QM by R square. So this is the calculated magnetic field which is due to this particular pole. So this, how did we calculate this magnetic field? Due to this force, because suppose this current carrying loop is there and it is carrying a current I. If it is at a magnetic field B, which is due to this pole, right, then it will feel a force BIL, and therefore this and this force to equate, we can find this is the magnetic field B that the pole would create, and this is how much, mu naught by 4 pi QM, the pole strength, into divided by R square. So this is a very, very crucial finding which we may use in many other derivations direct as this kind of result. So this is the magnetic field produced by a single magnetic pole.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.